Ladies and gentlemen, welcome to the Interconnect 2015 DevOps and Continuous Engineering Keynote. Please welcome your hosts, General Manager Cloud Platform Services, Steve Robinson, and Vice President Internet of Things, Continuous Engineering Solutions, Brett Greenstein.
Good morning. You made it through another day of Vegas. It's good to be here, right? So we're going to spend the next hour talking about DevOps. How many of you have attended a CNSI Pulse show before? Yeah? How many a Rational show, Innovate, Orlando? So you are the guys we need to pull together. Because when we talk about DevOps, it's both the dev side and the ops side. So I think one of the critical things here is to bring these topics together, and I think this is one of the benefits of this show, is we can get both topics on the same stage because really they're both affecting each other. And DevOps is affecting all of us. We're all moving to a world where we're always on. It's more about becoming a utility than just simply shipping software or shipping embedded systems as well. So that's what we're going to cover with you today. I've got my brother from another mother up here, software, hardware embedded, and we're going to have a real good time covering both of these pieces. Get my button going here. So let me start off a little bit on the software side itself. And some of the key changes that we're seeing here have been radical. A lot of advancements over the past year, specifically around the way we do DevOps now around software and as we now move to the cloud. Some of the things we're doing now involve direct activity with our customers. The good news is we've got lots of data. The bad news is what do we now do with it? So how are we then progressing and how are we dealing with all that information that we're getting back? We're also seeing new programming around design thinking. At IBM, we hired more designers over the past year than any company on the planet. If we're going to access and do mobile and get directly involved with our customers, we've got to build better products. We've got to understand how that fits into the life cycle, and it's going to affect our overall designs. And then finally, we're seeing even brand new methodologies on how we do DevOps. We went from waterfall to agile, and even now we're moving to extreme agile. You know, we're doing things in the labs now like pairs programming, where we have two programmers anchored to a single terminal. One programs, the other learns over top of them. They switch the panel over, one program, and the other one looks at them. 4-hour blocks, take a lunch, another 4-hour blocks. The most hardcore programming that I've ever seen, but it's yielding tremendous results. So that's on the software side. Brett, why don't you tell us what's kind of changing now on the hardware and the continuous engineering side?
Of course, thank you. So in continuous engineering, we are focused very much on supporting product development, and continuous engineering has never been stronger and is being accelerated by the opportunities created by the Internet of Things. It's driving acceleration. So DevOps and CE, continuous engineering, are really two sides of the same coin, as Steve mentioned. You know, it's the application side as well as the product side. If you're creating software applications, you speak of DevOps. When you're creating physical products with embedded software and connectivity, you speak of continuous engineering. Where things get really interesting is that today's smart products are a mix of physical and software. Now, the principles that were outlined for DevOps are inherent within continuous engineering. When you bring products to market, businesses want to be able to provide a variety of user experiences, which may differ by market or geography, while minimizing changes to the basic product design. This involves thinking in terms of product lines, whereby designers can strategically reuse valuable design knowledge across the lines. This type of design thinking stretches throughout the entire design process. Continuous engineering also emphasizes the idea of agile development. In this case, we call it continuous verification, but it's the same idea. It's shifting left as much of the verification and validation of designs as possible to avoid unnecessary integration challenges and rework down the road. And finally, feedback is incredibly important in the world of continuous engineering. The Internet of Things now provides an unprecedented amount of data about how products actually perform. This knowledge, which was previously unavailable or was unlocked in different operations departments and databases, is now available to support continuous product improvement.
Thanks, Brett. So in the next 58 minutes, we've got a fantastic agenda set up for you. We've got some of the best in the industry to talk about some of the changes that they're seeing. We're going to talk about entrepreneurs. We're going to talk about how this affects the enterprise. And we've got several customers that are going to share their experiences with you as well. So buckle up. It's going to be a great ride. So let's start off by taking a quick look at what our customers are doing in this space as they talk about DevOps and continuous engineering.
Consumer expectations are changing day by day, if not hour by hour. In order to overcome those challenges, we need to be more agile.
DevOps is imperative for our innovation model. One of the problems that we encountered very often were customers complaining or putting reviews on the App Store without us being able to quickly recreate those problems. We learned of this product that was available on Bluemix called Mobile Quality Assurance. It basically allows a client, no matter what they're doing, to quickly give us some feedback. Then we're able to very quickly get a root cause of the problem and then solve the problem.
This feedback is actually very positive and helps us learn and helps us make our application better.
And it's not just the complexity of the number of different permutations our customers can order, but it's the complexity of working as a collaborative team across continents with far more suppliers and far more engineers than we've ever done with before. If you think historically, it could take us 3 days to root cause an issue. By putting the effort in up front into the tool set design, that's done in 30 seconds automatically with no human intervention.
Innovation is very important at Raytheon. We're always striving to come up with faster and better ways of doing things that achieve the same great results. So we don't want to compromise quality, but at the same time, it's very important for us to stay on top of the game and come up with innovative ways to do things. We've been able to do a lot of that innovation around the IBM Rational Doors tool.
In order to meet the demands of our business and our customers, development needed to deliver code faster. It was clear that I needed to focus on automation and DevOps in order to accomplish this goal. IBM Urban Code Deploy has helped us be a fully agile shop. As a result, the DI team can produce actionable data far faster than it could before.
From the time that we initiate a project in a matter of minutes, get all of the stakeholders added, all of the project members, set up dashboards and begin development, the whole way through testing, IBM DevOps Services is supporting our process. The benefit of having the infrastructure in the cloud is that now when we're talking with our clients, we're able to go straight to their business objective. We can start talking about how we're going to execute against their mobile strategy.
Fantastic. So let's start the discussion with the entrepreneur, with the startup. I find many times that the tools and the processes that the companies use when they have no capital, they have very little asset, they're trying to make their name in the market, sometimes can be a significant beacon with regards to what we're going to be using back in the enterprise as well. And there's been significant changes in the space with the advent of the cloud, the accessibility to have almost unlimited databases, unlimited compute capacity, access to middleware. We're seeing speed and innovation in the way we build code change dramatically than what we've seen over the past decades. One of the best quotes that I have here is from a guy that really knows the entrepreneurial space well. He's one of the loud voices in that space. It's Jim Dieters, and it's 2 guys in a Starbucks now have access to as much computing power as a Fortune 500 company. So let's pull the thread on that quote, and I'm extremely pleased to have Jim Dieters with us here today. So Jim, come on up and let's have a little chat. Good to see you, Matt.
Morning.
Good to see you. Good. So Jim, why don't you tell the audience, we've been working together a little bit. You've got a fantastic set of innovator spaces called Galvanize, and this is kind of where companies come to start up.
Yeah, a little bit about Galvanize. So think about a modern campus where you have the intersection of entrepreneurs intersecting with large companies, IBM and others that are creating an ecosystem. At the same time, we insert students that are learning software engineering and data science on the same campus. So think of this great big melting pot. You walk into a coffee shop where anybody can be, and you have this intersection of several hundred startup companies mixing with large companies like SoftLayer and IBM, the Blue Mix Garage where clients are coming. And it's built on what we call community, curriculum, and capital.
Right.
So in summary, think of it Disneyland for nerds. Kind of like what you created here in Vegas.
That's right, that's right. Oh, there we go. And we've been doing a little bit of an experiment. When we launched Blue Mix, we decided, could we take IBM and co-locate them with Jim at Galvanize? And could we both learn from the entrepreneurs and also have them rub off on us at the same time? And we've been having some of our enterprise accounts come back and act like startups for the week as well when they come through.
As we like to say, the context for the environment really matters.
Fantastic. So let's talk a little bit about what we see in the marketplace. You know, we had innovation is the new currency, and I think when we look at startups, it's all about innovation, it's about speed, and it's disruption. So as you work with the startups, you know, what kind of their mantra, and how do they kind of get going?
Well, I think we've watched this change happen over the last several years and then accelerate. And we like to call it this entrepreneurial renaissance. And this renaissance has shaped the way we program, the way we consume, the way we buy, the way we order our taxi services, the way we get our groceries delivered. And it was a confluence of several things. When I first started building software companies years ago, we invested tremendous amounts of money in infrastructure and bandwidth, et cetera. At this time, we have a large population of millennials coming of employment age. At the same time, we have the confluence of ubiquitous compute power and creativity intersecting at this very unique point in time where we have this explosion of creativity happening and new ideas exploding. And the access to creating anything, as my quote said, there are people in this room, people around the corner, people on the other side of the globe, that the only real limitation now is their own creativity and thinking.
Right. And when you bring in a new company, like I said, I've been at your campuses many, many times. Never see a rack room, never see a server. It's just how they think these days, right? You're going to be born on the web. You're going to go directly to the cloud, and you're going to be using these utilities just on pennies on a dollar to get up and going.
The speed is phenomenal.
Right.
And in startup land, we even have a funny word for failure, right? We call it pivot.
Pivot. Fail fast. We used to call it, now it's called pivot, right?
You know, this is the new terminology, but at the end of the day, the speed at which an idea can go from idea or a business insight into actual production code is literally a moments of clicks and several lines of code.
Right.
And you can start innovating on business models and business processes. And entrepreneur for us isn't just about those that are taking risks and building things. Entrepreneur is something everyone should be thinking.
Right.
I think of an entrepreneur as a creative, resourceful person. And I don't know any company on this planet that isn't interested in that. Do you mind if I ask?
No, you always ask the audience here, so let's.
So I've had the pleasure of getting to speak in front of groups over the last couple years, and I like to do a quick survey. And I don't know if it's too much of a challenge, technical people, I can see pretty well. And I know it's early in Vegas and we love to sit still and do nothing. But who in this room, I ask the same question over and over again, who in this room considers themselves an entrepreneur? Raise your hand, please. I'm going to take a picture of y'all too, if you don't mind. There we go.
Jim's the master of the selfie. Crowd selfie.
Here, we can do that too. There we go.
Very nice.
That was,
about half, I think, right?
There was a pretty good cross section of people, and every time I ask this over the last several years, the audience gets deeper and deeper in terms of handling.
And I think that's critical too, because a little bit of parallel is what you see, on the galvanized campuses and with the startups. Is that applicable to enterprises? Should they worry about it? And of course, we get into the disruption comment. You may not be worrying about it today, but there's footsteps over your shoulder here.
If you're not worrying about it when the skies are sunny, I'd be really surprised. I mean, the pace of innovation, and I get the opportunity to meet with executives from a lot of large companies, and they're absolutely thinking about how to accelerate complete business model transformations. I mean, look at just the innovation that's going to happen with the automated automobiles and what's going to transcend transportation, and every industry will be consumed by technology at some point. And that speed and the number of innovators that are hungry to eat your lunch is growing exponentially.
And I know your agenda, you're speaking as much now to corporate chief digital officers, chief innovation officers. There's this growing need of how do we build this innovation into our systems? How do we change our processes? How do we do A/B testing? How do we pick up some of the startup skills and factor them into our process as well?
And I'm surprised at the executive acceptance of that.
Yeah.
We'll see the will of the organization.
The top gets it.
To adopt it. They absolutely do. And I think as you're here looking at modernizing your infrastructure, right? The compute power and the modernization that's happening sort of at a grassroots. And it's a lot easier for a startup, right? There isn't the baggage of decades of legacy code.
Right.
So but by simple fact, startups have an advantage of not having the legacy. But at the same time, as everyone here is looking at modernizing their platforms, at the same time, they need to modernize their talent base. Right. And we work really hard. We run our own education programming, teaching software engineering and data science skills.
Right. And you're able to get skills, and it's a radical shift, but you're actually able to get programmers that have been more traditional programmers to new styles in a fairly short amount of time, right? You get their G School, 12 to 24 months.
The G School program, the flagship program, was a 6-month program that literally was designed to eliminate the need to go to a computer science school.
Right.
And we have amazing engineers that are coming from musical backgrounds, from literature backgrounds, right. And they're getting jobs at IBM and startups and Facebook and Airbnb and Asana and all sorts of unique companies. And I think hopefully one of our students is here in the room that works for IBM now.
Fantastic. Well, thank you, Jim. And if any of you have a chance to either be in Boulder, Denver, San Francisco, Jim's expanding, just to take the day to go out and see one of these incubator spaces and get a feel for the vibe that's coming out and the transformation that's coming up. So, Jim, thank you very much, and thanks for joining us today.
Thanks for having me.
So we start with the startups, and then let's take that thought and drive it into the enterprise as well. And we have many customers that are really starting to push the envelope quite heavily. Hiscox Insurance is one of these that's out of the UK, focusing on small, medium business, and are really disrupting the market. Got voted one of the top innovators for small, medium business, and we're very happy to have Gareth Wharton, their CTO, here today to talk about their DevOps journey and some of the changes they've been going through as well. So, Gareth?
Hey guys, thanks very much for having me. My apologies for bringing the London weather with me. Hopefully we can have some fun today. So, a little bit about who Hiscox are. As Steve was saying, we're an international specialist insurer, about 3 billion of turnover. And we insure some cool stuff, so we do satellite launches, we do kidnap and ransom, but also specifically in the US, we do online selling of direct business insurance to the US. So, any IT contractors, Hiscox should be one of the companies you're talking to. Okay, enough of a sales pitch from me. Why DevOps? What was Hiscox trying to do when we started on our DevOps journey? So in 2012, we did a review of our IT strategy, and the common feedback that we got from our business was we want to be more nimble, that IT was slowing the business down. We couldn't work at the pace they wanted to take advantage of new technology. And the business said to us, look, we realise that technology is a key part, especially for our online business, that we really need to be able to innovate and move more quickly, and technology is a key driver for that. They also talked about self-service, but when we actually looked at it, self-service wasn't what they wanted. They just wanted reliable change, but at a much faster rate than we could deliver it. So we were working on a significant transformation program called the Da Vinci program. So this was replacing one of our core underwriting systems, but with a web front end. And as Steve was saying, for a company that's based out of Lloyd's of London, we've been around for 100 years, we started off this program with some big rules about how we would all operate. And one of the key ones was think like a startup. So for all the project managers, we always talk about the speed, cost, and quality triangle. But Hiscox said for this project, speed is most important, not the quality or the cost. So if it cost more, but it gave us speed, then we were willing to take that trade-off, which made the project really fun to be part of. But it made us think in a very different way. And then the other key piece was that we were going to be the one team. So it wasn't business giving requirements to IT. We'd all be in the same room. And we seconded people out of the business and out of IT, put them all in one space and made them just one team. And that really helped us. And then finally, Hiscox yesterday was very much a silo IT organization. We had a stovepipe for dev, one for sys-test, one for UAT, one for, for our test environments. And it just made things happen very slowly, that people who wanted to bring change in needed to get the dev guys, and then the test guys, and then the support guys, and the infrastructure guys. And there was a real misalignment of goals. So we had to change this to increase the speed that we could deliver. So what did we do about this? Well, the first thing that we did was convince the CIO. So this is Stefan, my boss, who's actually a business person that came in to be a CIO, and that's really beneficial to us because every time he said, what's the business justification? So we talked to him about breaking down the silos, and he said, yes, this makes sense to me. So we did a fairly significant IT reorg where we aligned all the delivery teams to the head of IT that was looking after that piece of the business. So once we'd done that reorg, we started to look at which systems that changed the most and where we should focus our effort. So we looked at the highest change systems, and we did what's called a SIPOC, which is a Six Sigma process where you look at inputs and outputs and find out where wait times are. But what we found is that for our current projects, that it was so difficult to take people out of their day job that we would actually target the Da Vinci program. So that's where we focused most of our effort. So specifically for that project, what did we do? So what we did is we said, right, there's going to be just one team. Again, the slight cultural shift, it's going to have everybody in it that needs to make a change. So whether you're a dev, test, support, release, whatever, you're all in that team. And it was a business and IT team. And what we said is that we're going to create the day two team. So not the team that was getting the first product out, the team that would run the project for the 10 years that it might be around for. So the day two team were doing all the releases, and we call this team the pit stop team because it's got everything it needs in to make that change. So we did a huge amount of work changing the culture of that team. We're very much agile, so it's 2 weekly sprints, so we had to teach everyone that moved from waterfall to agile. But we also said we had to completely retool and very different range of technologies that we previously used. So we give people the go button, we let them make the releases, but we also give them the pager. So if you do the release, you've got to do the support afterwards. And it drives good behavior so that the quality of the release, if you know you're going to get the call at 4 in the morning, it drives you to release good code. And also that it stops you wanting to do boring things, so it naturally led them to do innovation, especially around the automation piece, that if they have to do all the releases, well, they've got to put up with the manual processes, so they naturally want to automate. So this was a massive change for us. And the tooling, the significant change, getting everybody to go waterfall and everybody to take on the new tools was a big deal to us. So what were the benefits of doing this? So on the left here, you've got an urban code deploy calendar showing all the deploys we did. So from July to October, when the project first went live, we did 790 releases. And it was a seismic shift for Hiscox. That very much that we used to hate doing releases. They were big, scary things. And we said, right, okay, bring that pain forward. If you can make it boring and low risk, there's far less chance of us getting it wrong. And it changes the dynamic in the team that they go, okay, right, if I've got something that's ready to go, and I can get it out of the door really quickly, let's do it that way. So we saw a significant increase in the number of releases. So, what did we see the benefits? So historically, this product a year or so ago, with a manual release, we needed 8 staff taking 3 hours. So there's a significant cost in doing a release. But when we automated the releases, we got it down to just 2 staff, and it's our ambition to get it down to 1. And these releases now take less than 20 minutes, so it's significantly faster. So the benefits we've seen, 89% reduction on time to release and a 97% cost to release. So it's a very significant change. And what we found, we got the release down to about 5.5 minutes, and then when the releases were starting to take 7 minutes, the whole project was panicking. So from when it was 3 hours, we got it down to 5 minutes, and they were now scared when it took 7 minutes. So there was a massive change in the culture and people's expectations of how quickly we could do a release. So in the go-live week, we did 47 releases. We did 19 on one day. Just in that week, we reckon we've saved about £75,000 on release costs, just not having that number of staff needed to do those changes. And it wouldn't have physically been possible to do that without growing the team. And I'm sure, as you know, when projects go live, they tend to suck in resource from other projects. But we didn't see that. We managed to do all these releases with just the same size team. So it's not all about the automation. There's other pieces to the puzzle as well. What we found is if you know who's done what and when, it's much, much easier to have consistent state across all your non-production environments. So we know that they're all in consistent state. And it makes audit much easier when something goes wrong. Because the incremental size is much smaller, it's much easier to work out what's gone wrong. And as the guys were talking about earlier, training the team is much easier because they've got a set of automated tools. They don't need to know the legacy of you need to do this registry fix here, this fix there. So it was much easier for us, and much quicker to onboard our team. So it's all nice to say the stats, and they all look cool up on stage, but I'm sure, like me, that you will have an annual review with your boss. This was an email that the project sponsor sent to my boss saying, "You guys rock," and that's always good to walk into your end-of-year review saying, "Didn't we do a good job?" So I'm really proud of what the team has done, and it's made a massive change to us. So a couple of final thoughts. Because we only need 1 or 2 people to do the releases now, we can do them in a much different way. So a guy did them on the train while he was travelling home. And this is St Paul's Cathedral in London. Someone rang as the guy was on his way home and said, "We need to do a release." That's him on the iPad doing the release. So it just changes the dynamic of how we work now. So just some final takeaways from me. It's all about the people, the process, and the technology. If you can't change all of them, it makes it much more difficult, and it will limit the success. It is hard. With no doubt, the people and the culture is far more difficult than the process and technology. Techies always love new technology. That bit was a reasonably simple transition. But it's hard, but it is definitely worth it. And over time, it will tip. It can take time, small incremental wins. Last year was a real struggle for us, but this year now we've delivered these benefits. Everybody's saying, "Come and help me, come and help me," and it's really people are coming to us rather than us having to go for them. And then my final thought, John Fletcher, who works with me and is the brains behind most of this, is presenting this evening. So if you want to come and see more about the tools and how we've done this, come and see John present at Mandalay Bay this afternoon. Thanks very much.
Gareth, thank you.
Thanks,
Thank you. And I think you can see from his comments, I love the case studies. It definitely shows that DevOps is real. Doing your submission from the train, man, that's gutsy right there. And DevOps is now. It is now the time to take a look at this. One of the key things we did last year, we had Gene Kim come to us. Gene is one of the clear voices who is writing about the state of DevOps, and he was really dazzling us last year with cases around the speed of which Google and Amazon and the commercial vendors are moving in this space, how many pushes they do every single day, how they keep these dynamic environments up and going. And we're happy to have Gene back in video to kind of help us to see what's happened since he last talked to us. So with that, let me tee up Gene and let him see, how is DevOps making a bigger impact on the enterprise and just what's changed over the space from when he talked to us last. So, Gene?
Hi, everybody. I'm grateful to have been a part of the IBM Innovate program last year, and I'm delighted to be a part of the program here at Interconnect with the entire IBM community, spanning business operations, dev, test, and ops. I agree with Steve Robinson. DevOps is important, and DevOps is happening now. It's important because DevOps is what we need to be able to be fast and reliable. And it's not just the unicorns doing DevOps who are doing tens or hundreds of deployments per day. Increasingly, it's the horses as well. Large, complex organizations such as Capital One, Raytheon, Disney, Nationwide Insurance, and others are all achieving unicorn-like outcomes, showing us that horses and unicorns are actually the same species. In fact, it's not unicorns and horses at all. It's the thoroughbreds versus the horses being sent to the glue factory. Organizations that remain complacent doing annual deployments in large waterfall processes inevitably lose in the marketplace. Our research shows that DevOps not only increases IT performance, but it increases organizational learning, job satisfaction, and all those other things we need to win. In October, I held the DevOps Enterprise Summit with the fantastic support of IBM. We assembled the best leaders who are driving DevOps transformations in large, complex organizations, many of whom I met last year at the Innovate conference. Certainly there were some amazing stories of new services being created using all the latest, greatest technologies, building them from the ground up, with DevOps principles in mind. But my favorite stories were those organizations tackling their messiest legacy core business processes. These were the brownfields, the system of record applications, the applications that have been around for at least a decade, like that 30-year-old COBOL mainframe app. According to IDC, 60% of CIOs see DevOps as how they will achieve speed and address sprawl in a world of mobile, cloud, and open source applications. I'm holding the DevOps Enterprise Summit again this October. I invite all of you to join our community of enterprise technology leaders who are all helping each other successfully adopt DevOps in their own organizations. Trust me, I've never learned as much as I did last year, and it's all going into the DevOps Handbook coming out later this year. And most importantly, I encourage all of you to learn as much as you can here and take full advantage of the over 300 sessions, labs, and workshops available this week right here at Interconnect. Have a great conference, and I hope to see you soon, and thank you.
Ladies and gentlemen, please welcome back Brett Greenstein.
Thank you very much, Gene. IBM is proud to be a sponsor of the DevOps Enterprise Summit. And if you want more information on the DevOps Handbook or Gene's conference later this year, please send an email to the email address up here with the subject line IBM. Now, on to continuous engineering. The products we use, like cars, planes, phones, medical devices, are becoming increasingly complex. This is accompanied by increased complexity in the software and in the data, which in turn drives complexity throughout the engineering process. Continuous engineering is IBM's response to help clients deal with the challenge of making smart products. But continuous engineering is also becoming increasingly relevant for clients that derive value by providing services around connected products. It's becoming more than the product. In fact, the ability to build a business model around services for a product has never been stronger, as more and more devices are connected and generate data within what's being called the Internet of Things. So what's being connected? That's right, cows. Cows generate over 200 megabytes of data per cow per year. We're also talking on the other extreme about jet engines that generate a terabyte of operational data on each flight. Billions of things are being instrumented and generating data, and the amount of data can be overwhelming. But for forward-looking companies, it can also be a huge opportunity. In fact, McKinsey & Company predicts that the Internet of Things will affect between $2.7 and $6.2 trillion of business value by the year 2025. This is coming from people deriving new services and new ways of doing business, and manufacturers are not ignoring this opportunity. 75% of them are exploring Internet of Things. 62% of executives believe that late adopters to the Internet of Things will fall behind. These changes are occurring now. More and more devices, both existing and new, are using sensors to generate data. Data volumes are growing exponentially, and feedback about operational performance will shrink from months to weeks to days, hours to real time. You have to ask yourself, as a manufacturer of products and services, when do I need to act? When are my existing engineering and business processes no longer adequate to deal with this new reality? When will customers expect more from us? And the bigger question, of course, is what should you do? The answer is different for different businesses and different industries, of course, but one thing is certain. The power of analytics cannot be ignored. It was good enough in the past for really great engineers to be very smart and to absorb a lot of data from the field and make their own decisions. But the amount of data being generated by connected products isn't comprehensible by any single person anymore. And the level of insights that are possible will need support from analytics. There are counterintuitive design decisions that can only be seen through the use of analytic methods. Now, a lot of us in the room love all the new cool technology, the underpinnings of the Internet of Things, myself included. Since I'm a technologist at heart, I just love this stuff. But the Internet of Things is about more than putting sensors on connected things and generating data. According to Tim O'Reilly, it's about human augmentation. It's changing people. We're not letting the Internet of Things teach us enough about what's possible once you add sensors. There is a complex interplay of people, interfaces, and machines that's going on. And the question is, how do we create feedback loops from devices to people? As an example of this, Tim cites Uber, which we all talk about as an example of the Internet of Things, an early adopter. We're all familiar with the ability provided by Uber to schedule transportation with your smartphone. But Uber's really delivering a greater value. As Tim says, an Uber passenger is an augmented passenger who knows when the cab will show up. Uber is about eliminating slack time and worry. Now, the world is changing around us right now. Smarter products are manifesting themselves in every industry. More and more companies are exploiting the opportunities to deliver new types of customer value. But companies that dare to ignore the possibilities generated by the Internet of Things are like the frog who increasingly in hot water does not realize what's going on and doesn't adapt. Adaptation requires thinking outside the box. We've seen in the past that early in the introduction of new technology, we all do things that look like the old market, but more efficiently. The Internet of Things actually, though, creates a new opportunity that's not provided by traditional value, but in new and different ways, but to deliver entirely new value streams, resulting in new and innovative business models, redefining entire industries. As a simple example, let's think of a car. Nearly all of us own one, some of us more than one, and what do we do with it? We drive it to work, we park it for 8 hours or longer, we drive it home, we park it for 15 hours or shorter, and let's say we spend $30,000 on that car, we can easily calculate what the price per trip is. It's pretty high. But we do that because we value flexibility. We want to be able to leave and arrive when we feel like it. But what if you could have flexibility at lower cost? Car2Go is looking to provide that flexibility at lower cost by making cars available to get from one place to another more easily. Now, there are examples in other industries. Power by the hour for engines, drilling services rather than investing in expensive drill bits, gallons of water moved versus buying pumps. The shift to services is happening in lots of industries. Now, ultimately, the value is derived by understanding people better, understanding habits and real needs, so we can serve them better with the things that we build. Machines and devices should support our life, not the other way around. I just saw where someone invented a way to graphically display the temperature of food in a microwave oven, so you know for sure if the food is actually hot, all the way through, not just the stuff you touch. I mean, how valuable is that? When you think about it, a microwave oven can't tell you when it actually completes a task just when the timer's up. What it's really designed to do is cook food and deliver it the way you want. So we can't accept timers and not knowing when things are ready. We need to expect it to serve us and to deliver the need we actually bought it for. Similar opportunities exist with other appliances and other industries. Our washing machine should know when we put a red sock in with the white socks. It should warn us that there's an impending problem. Connectedness and data, along with sensors and intelligence, can provide better lifestyles and deliver new forms of business value. Now, for instance, with all of this intelligence, don't you think it's possible that a price line for appliances would emerge where service people could bid on working to help fix our things before they break and come to us? Could a company like Staples emerge for appliances to provide spare parts? There's a lot of new possibilities. And it's changing the way people use and operate products. And of course, it's changing how all of us as engineers build and design them. So what's required? First of all, understanding context, understanding intent, but also sensing. And the feedback of data and information from devices, all combined with analytics to derive insight. But most importantly, innovation of your product or service is based on this insight. Continuous engineering is essential. Fundamental business transformation must be designed into the business from the top down. The human augmentation that Tim O'Reilly mentioned implies matching assets and consumers and operators based on location and need and price and value. It opens up all kinds of possibilities. The opportunity is tremendous, and the time is ripe for new models to replace old. Success requires seeing where needs can be met and having the courage to act on them. So now I'd like to show you a short video on the impact of the Internet of Things. And speaking of Bosch, I'd now like to introduce the Vice President of Engineering for Bosch Software, my friend, Stefan Ferber.
Thanks, Ben. Welcome to the Internet of Things. I'm Stefan, I'm an engineer. I'm connecting the physical world to the virtual world. Oh, can you go to the next slide, please? Yeah. This connectivity is in your home, in your car, the required energy. It connects you, your family, and your community. And how we do this? Basically, it needs three things. First of all, sensors, second, software, and third, services. So we come to the first, sensors. Bosch produces 2.5 million sensors every day, and Moore's law is helping us to make sensors smaller, cheaper, and more energy efficient. You all have them in your car, your smartphones, your wearables, GPS, gyroscope, temperature, humidity, heart rate, many more. As small as 3 millimeters. Yes, Physics 101 is some time ago, I know. Just compare it to a penny here on the screen. The second one, software. Software based on open internet platform is key. Bosch has become a big software company. We wake up every morning with more than 15,000 software engineers out of 40,000 engineers around the globe. Number three, services. In the internet, they come as software as a service. Hence, in the Internet of Things, you have to move, maintain, take care of real physics. That's why you need real people doing real service. Bosch is the Internet of Things company in mobility, for cars, commercial vehicles and bikes, in industrial technology, production, machines and logistics, for the consumer, in home, gardening, power tools, and in the energy and building domain, security cameras, heating, cooling. The Internet of Things is real. We have products for connected home and connected mobility in the market. And just here in January at CES here in Las Vegas, Bosch unveiled a new environmental sensor. This is the first combo sensor measuring humidity, pressure, temperature, and gas in a 3 by 3 millimeter package. This sensor can be used in a myriad of ways to monitor, manage air quality in a room by opening and closing windows, or managing the airflow. It can only monitor the fitness of your recommendation to secure personal well-being. It's key for home automation, environmental monitoring, as well as personal weather station forecast. In IoT, nobody can do it alone. Business ecosystems and shared open platforms are key to further advance interoperability, like here in Smart Home. Bosch, ABB, and Cisco started a joint venture and are inviting every other players to join the platform. The new company will establish a partner alliance that will open up all manufacturers, developers, and suppliers, products and services. So join the forces. And by the way, Bosch also joined the International Industrial Consortium. Richard Solly is talking about this later. You also should join there to do a test bed with us. Let's have a closer look at connected mobility. What innovations are out there? How Bosch keeps you safe and secure on the road. There are three key drivers behind mobility. First is electrification, automation, connectivity. With electrification, the gas station of the future comes to your home. This DC fast charger can charge a BMW battery to 80% in just 30 minutes. For electrification vehicles, public charging is an important key asset. Therefore, reserving charging station in advance, payment via smartphone is important. This is one of the software as a service offerings by Bosch. With e-bikes, electrical energy supports muscle power during pedaling. Bosch has become the market leader for e-bike driver systems in Europe, and we are excited to see them launch here in the US. Neon is Bosch's first all-in-one e-bike cycling computer with an integrated navigation and fitness function. Equipped with comprehensive offline functionality, Neon can be adapted to the needs of the rider with a smartphone app and online portal. Automated driving translates into our vision for an injury-free and ultimated accident-free future. Bosch develops a variety of sensor systems to enable automated driving. For example, radar sensors and monostereo video cameras enable driver assistance systems. By coupling radar and video technology, traffic jam assist controls movements of the vehicle in congested traffic. Connectivity. Bosch is making cars an active node in the internet. By networking vehicles, Bosch is improving the comfort, safety, efficiency of tomorrow's mobility. Today, your car is already a powerful parallel computer with more than 80 control units. Most new cars feature internet connectivity anyhow. Just one of the control units is the engine control unit. We produce 20 million per year. 3,500 engineers work in parallel on 400 projects in our product line with about 1,500 variation points. We couldn't manage that complexity and fulfill the rigid automotive SPICE requirements without IBM product line engineering PLE support. The agile and close relationship between Bosch and IBM implementing additional features in PLE is outstanding. So IBM, thanks a lot for that excellent work. With connected cars, multiple use cases arises. For leasing car fleets, examples are shown here how we can leverage vehicles as assets on the road for more efficiency. Creating value out of data for the driver or the fleet operator is key. Security is the big elephant in the room. We place a great value on security and privacy because in the Internet of Things age, trust is as important as ever. And our privacy policy dates back to the year 1990. Our company founder, Robert Bosch, said in 1990, I've always acted according to the principle that I would rather lose money than trust. The integrity of my promises, the belief in the value of my products, and my own word of honor have always had a higher priority for me than a transitionary profit. So, ladies and gentlemen, I hope that you share Bosch's excitement for the tremendous possibilities with Internet of Things, as we continue to merge our Invented for Life product portfolio with this fast-evolving Internet of Things. Integrating the physical and virtual world promise to enrich our lives. Welcome to a new world. Welcome to the Internet of Things. Thanks, Beth, for having me. You need it?
No. Okay. Thank you, Stefan. Now I'd like to introduce Richard Soley, Executive Director of the Industrial Internet Consortium.
Thank you, Brett. So the internet changed everything. Absolutely everything in the universe has been changed by the internet. In fact, Bill Gates said this in 1999. How many people agree? Come on, wake up. It's not that early anymore. The internet changed everything, right? Okay, nobody agrees. You're all asleep. I can't see you anyway. I'm just faking it. I actually am here to tell you that maybe the internet hasn't changed everything, and maybe we ought to be looking at other things the internet ought to be changing. You've got a hint from a previous couple of speakers. But let's talk about where things have changed. One great example right at the top of this picture. Remember boomboxes? Anybody? There are some people out there missing hair like me. You remember boomboxes. You, sir, you remember boomboxes. You right there. Nobody listens to boomboxes anymore. We listen to music from computers. Those computers could be desktops, for those of you who remember what those are, laptops, or more likely they're computers that you carry in your pocket, like this one. It's a BlackBerry. Believe me, it's a computer. What's so funny? I don't get it. I'm not going to go through this whole chart. I think you've seen this. We watch movies on computers. We read newspapers on computers. I'll explain what newspapers are to the younger people in the crowd later. But the point is, entertainment's changed. We've changed the way that we get our news. We've changed the way we make music. And the internet has done that by MP3s, thanks to Fraunhofer, and the availability of things like iTunes and so forth to get access to music, access to movies, access to books, and so forth. But I'm here to tell you that there are some things that the internet has not touched, where internet thinking has not happened, where people don't think about how do I use the internet to make my systems more efficient or to change the way that I connect systems. This is an example. In 1980, when I was 3 years old, I worked on, you have a terrible sense of humor over here, right? This group right here.
I worked on what are called programmable logic controllers, PLCs. This is a picture of one. It's called, at the time it was a Modicon 584. It's been sold and bought and sold and bought. There's a newer version, which is made by a company called Schneider Automation, actually, French company. And the way that you program these systems was something called ladder diagrams. 35 years later, the way you program these systems is something called ladder diagrams, sort of like COBOL for PLCs. The point is, internet thinking hasn't happened there. Not only have we not changed the way that we program these systems, but if we want to get information from our operational systems, like these programmable controllers, we were working on one that ran a brake lining plant in Michigan near Detroit. Detroit used to be a city. Oh, sorry about the little Detroit group back over there. The way that you get information from these systems so that you manage your inventory, manage your work in progress, and so forth, in 1980 was you printed it out, you carried it across the floor, and you typed it back in. Guess what? Still do it that way. Operational systems and information systems not being connected. There are a lot of examples. I'll give you a couple more really quickly. This is in 1950, the electrical grids that transmit and distribute power from electrical generators around the world. Or, for example, in the United States, where there are 3 power grids, east, west, and Texas. That's, by the way, true. Expected that there were a small number of power generators and there would be hundreds of millions of power users. Of course, that's changing with electric cars, with solar arrays, with wind arrays, and so forth, but the power grids look pretty much the same. You can count the number of microgrids that do something more intelligent, that parse information around that network on just a couple of hands. The point is, internet thinking hasn't happened there. I'll give you one more example. You'd expect when a jet pulls up to the gate, that terabyte of information that Brett mentioned, that the jet engine has collected in terms of performance and so forth from during the flight, you'd expect the jet pulls up to the gate, connects to the Wi-Fi that every airport has, uploads the data to the jet manufacturer, whether that's Pratt & Whitney or Rolls-Royce or General Electric or whomever, and they do real-time predictive analytics on that information compared against benchmark data of hundreds of millions or at least millions of hours of that jet engine on that kind of jet, and then make a decision about how to make it more efficient, or maybe that it needs to be replaced before the jet takes off again. Places a call to the maintenance base, and anyway, none of that happens. What really happens is, still 55 years later, my subtractor is not working today, somebody plugs a cable into the jet, downloads the data, takes a look at it, decides whether maybe something ought to be done, sends that information if he's got time before the end of his shift, etc. It's a lack of connection between the operational systems and the information systems. Lack of internet thinking. So we've seen these changes. We've seen this industrial revolution in the late 19th century where we moved brawn to steam machines, and that engendered a huge leap in productivity. End of the 20th century, we saw the internet revolution where we said we can take some of that connectivity away from people and move it into computers, and intelligence as well. And I think what we need to do is apply that internet technology to that industrial technology, and that's why we call that the industrial internet. Appreciate the mention from Stefan. That industrial internet is the application of Internet of Things technology to industrial systems. What's driving that? I think you've already heard this. Technology, you've got connectivity everywhere, you've got big data analytics, you can do much better than you could do just a few years ago because you've got convergence of all these technologies. Where do we go from here? A lot of different things. You've seen some examples. I like to categorize them as smart connected products. That's products where there's IT in the product, where we've heard about manufacturing and how to do manufacturing better. And smart complex systems like smart cities and so forth. This is not going to be, you've heard the word collaboration several times before, this is not going to be a closed ecosystem. There's no way. The whole point is connecting across my supply chain from my suppliers to me, to my customers. No one company can go it alone. We're going to have to work together. I love this quote from Jeff Immelt. He's the chairman and CEO of General Electric. If you went to bed last night as an industrial company, you're going to wake up in the morning as a software and analytics company. You need to start looking at your products and deciding which of those can be services, sort of the way Brett talked about jet engines. Will I be able to lease some of this technology and move CapEx to OpEx, change the way I sell those products? And what impact is that going to have on the way that I service those products? What impact is that going to be on the way that I sell them, and so forth? How are you going to collaborate with your competitors? Co-opetition is really central to where we're going. That's the purpose of the Industrial Internet Consortium. March 27th, 2014, 5 companies came together, AT&T, Cisco, General Electric, IBM, and Intel, in alphabetical order, to work together to build test beds, to test ideas about how we apply Internet of Things technology to industrial systems and make those systems more efficient. We thought we'd have 50 members by the end of 2014. In fact, we had about 120, and we today have about 150. So there's a lot of interest in building Internet of Things solutions for industrial systems. I'm definitely not going to read this slide. This is some of the large companies that are participating. You can see they're from all over the world. Bosch, for example, was one of the first to join after we went public. A lot of small companies as well. In fact, 2/3 of our members are small companies, and as well a large number of research organizations, universities, and so forth. I just want to leave you with the thought that this is going to change the world. You've already heard some examples. 20 years from now, products aren't going to fail without knowing they're going to fail. They're going to call home and say, get a spare part because I'm about to fail. Thanks for your time. Think about industrial systems and how IoT is going to impact those systems.
Thanks, Richard. Always love listening to Richard talk. And he'll be playing in the lobby bar for the rest of the week. You know, he's got that routine down pat, so he's going to be great. So a lot of good discussions, a lot of good customer stories here as well. You've seen some of the folks in the industry talking about what's going on. But let's bring it all home with a demo here. So we have a lot of great announcements this week, and you kind of see our activities focused in 2 main areas. One is focused on improving the overall life cycle around DevOps, and then more importantly, the more we announce on the hybrid side, how do we deal with the complexity of deploying code that may span multiple environments? So with that, to bring a case home and actually show some of this in action, let's bring Sky Matthews up to take us through a great demo here.
Thank you, Steve. Okay, well, if any of you were at the IoT keynote yesterday, you may have seen an example of an Internet of Things industrial scenario like Richard talked about, where there was an actual set of industrial equipment, and the operator of that equipment is using data collected from there to improve and optimize and do predictive maintenance. Well, now we're going to take a look at how DevOps and continuous engineering are coming together, and with that show some of the new things that you can do. So instead of the scenario that we talked about yesterday with the operator running the connected devices, today we're going to look at the manufacturer perspective. So for this demo, we're going to be the manufacturer of those industrial devices, a set of fans, and we've built and shipped our first set of connected fans. And what we want to do is now take Richard's advice and transform ourselves to really lead the market in customer service and start innovating new services and new capabilities around those connected fans. So we're going to monitor the customer deployments of our fans to identify potential problems and dispatch service technicians to address those problems before the customer even realizes there's any issue. So to do that, we're going to have to provide our customer service reps with a new application that provides a map. And that map is going to have a color-coded display on it to show all our installations and what their status is. And then the customer service rep can look at the indicator and drill in and see the actual performance on the device. And then the service rep can, if needed, call a practitioner or technician to go out and check that device or do some maintenance and give that technician all the data they need to go and correct the problem. So with that, what we want to do is take a look at the services that we are going to use to actually build and deploy this app. And just while that's popping up, I'm going to walk over, log into my laptop. So we're going to start with a new service that we brought out last year called the Internet of Things Foundation. And that's a capability that's hosted on Bluemix and basically allows us to connect remote devices in, and it provides a broker as well as a time historian database to actually store the data. So on top of that, we're going to use our track and plan. Here, sorry, here's the project space that I've got loaded. Let me take a look at the particular project details. In the coding, we've got a set of assets that we're going to use to deploy. We can also see that this is a nice environment for team collaboration. So we want to make sure that there's a collaborative view of the team. We've also provided some facilities for social engagement, like liking the project, accessing it on Facebook and so on. So inside our IDE environment here, we have 3 core capabilities. We've got the code editing, and there's a rich IDE, supports multiple languages. We've got, on top of that, you can also use Eclipse if you want as an environment on your desktop, so you don't have to use the web IDE. We've also got a set of capabilities for agile tracking and planning, and we're going to take a look at that in more detail. And then finally, we've got capabilities for managing build and deploy of this software. And that capability set is something that we're extending rapidly to cover hybrid environments, and we're going to look at that. So let's drill in on our track and plan service here and take a look at the actual backlog. So first I want to take a look at the backlog of requests, and the first thing I'll see on there is a request for this new feature for the customer service app. And that gives you some details on you can see here, for example, the high priority. If I open that up, I'll see some more information about this particular feature and some details that we need to provide our dev team to implement the feature, and also to track the status. So we want to make sure that we know how we're doing as we progress here. One of the things that we can also do is attach links. So we might want to include other artifacts. For example, here we've got a user interface sketch of the actual app, and that shows us what the UI designer wants it to look like. So here's the geographic display, and there's a red dot indicating a particular device on there. And we drill in on that, we can see the actual data coming from the device. So this is what it wants to look like. Now we're actually going to look at the code and build and deploy that. First, let's take a look at some of the new sprint planning capabilities we've got. So we've integrated much easier drag and drop facility. So I can actually just drag my feature request, sort of user story, into the new sprint. It drags in any of the other dependent tasks that I have to implement in order to do this. And then I can actually see as we go here what the status is of our user story in terms of completeness. Next, let's take a look at what we need to actually do to build and deploy this app. So here's the code editor. I'm not going to actually go and show you the code, but you can see the list of artifacts that we've got here. And then you can see some new tools that we've added just in the last couple of weeks for sort of very rapid turnarounds, build and deploy and debug. So we really have integrated this deeply with Bluemix. You can see some of these new tools that we've added here. What I want to do is actually deploy this app into Bluemix. So I'm going to click that, get that going. And then while we're waiting for that, you can see some of the new capabilities we've added here, including something that's pretty interesting, sort of a live edit feature for Node.js apps. While it's waiting to deploy, I want to note that this is a really great environment for being able to take embedded developers like me and introduce them easily to the cloud and give them a productivity environment that allows them to get up and running. I see here that the app is deployed, so let's jump into it. Okay, there we go. So now I've got my dashboard up. There's a geographic display, but as you can see, there's actually nothing on it yet. So I didn't want to connect to our real devices. I actually want to do some testing with a simulated device first. So let's look at how we can do that. This is a pretty good example of a hybrid environment that Steve was talking about. I want to run the simulation on my laptop here. To do that, I'm going to use some of the new container services that we introduced on Bluemix, as well as our deploy environment here. And this deploy environment can describe orchestration of complex hybrid deployments, like we're doing. We've got the app, and we've got a simulator running on my laptop. And I can use the configuration tools in this deployment engine to connect to all kinds of deployment capabilities, including urban code or Docker or so on. So here's an example. Okay, now let's take that and actually run our test device simulator on the laptop. So the deployment tool is actually going to kick off a connection to my laptop and show you how to deploy to a remote device here. So I've got that running, and in a second we should be able to flip and see what's going on. You can see the status here. It's deploying. Okay, so let's look at that. Now you can see it's kicked off the process on my laptop. So if we jump back now to our geographic display, we should actually see some of the simulated devices appearing, and there we go. So we've got two yellow-coded dots here representing some simulation. They're just working off simulated data that we're using to generate this test. If I drill in, I can actually see the real-time data coming from the IBM IoT Foundation. And on there you can see we've color-coded when we turn from green to yellow or yellow to red. So that gives important information to the customer support rep that they need to actually go and troubleshoot. So this is the end of our story, the end of our demo. Sort of a good example of using Bluemix and our DevOps services to really rapidly innovate this fantastic new environment of the Internet of Things. So thank you so much for coming today, and I'll turn it back to Brett.
Thank you very much, Sky. Now, a few important things for you to know. There's no shortage of learning opportunities and networking opportunities here at Interconnect. So let's take a few minutes to take a look at what's coming up.
Hi, I'm Jonathan Fletcher from Hiscox Insurance. Come and listen later how we reduced the cost of our application deployment process by 97%. I'll tell you more during our session in the DevOps track a bit later. See you there.
I'm Becky Cole-Gomez with GE Aviation Systems. Our engineering organization anticipates saving up to 50% in key process-related activities. Along with John Hetrick from IBM Services, we'll tell you more about it during our session on Wednesday, Choosing a Continuous Engineering Solution.
Hi, I'm John Harris from Left Shift IT. Most large-scale enterprise IT programs deal with change rather than greenfield projects. In our session later today in the DevOps track, we'll be talking about how to automate that change in a continuous delivery model and reduce risk by handling environmental and test data dependencies using IBM Rational Virtualization and DevOps solutions. See you there.
Hi, I'm Bob from Island Training. One of our life insurance clients released a new product line and web portal 11 months ahead of schedule by adopting DevOps and Agile processes. To see DevOps in action, join me for extreme sprinting and a smoothie at the Mandalay Bay Expo Center in the DevOps Zone. See you there.
Hi, I'm Gary Thornhill from Sundata Technologies. Using IBM software, we've helped our clients reduce delivery costs on SAP projects by 50% and improve productivity by 80%. I'll tell you how during my session on Wednesday in the Continuous Testing and Quality Management track. I'll see you there.
I'm Deborah Thomas from Raytheon.
And I'm Barclay Brown with IBM. You know how when you're playing a computer game, it's really easy when you're a beginner to just get killed?
I just got killed.
So that's what we're trying to apply to a complex modeling tool like Rhapsody, is applying these gaming-style player levels.
So when I train users, I start them out at the lower level, and then as they gradually get better, we go up to the higher levels.
So we'll see you at our session Wednesday at 3:30 p.m.
All right. So what we have after this, we have the DevOps Continuous Engineering track, probably more expert sessions than have ever been brought together in a single venue. 400 of them going on. Some started yesterday, but getting ready to roll right after this. We also have the DevOps and CE Zone, so make sure you visit that as well. And then Dev at Interconnect to stay up to date with our latest things. Now, DevOps not only helps you build code fast, but we're also going to help you be fast. So you got to get down to Mandalay Bay within the next 30 minutes so you can jump into your next session. So with that, thank you very much. Thanks for joining us. Thanks, Brett. Thanks all of our speakers. Have a great time here at Interconnect.